So moving into the rest of chapter 8, your factoring skills are going to be very important to you. Let's start at the very basics of rational expressions. Now, rational expressions simply means you're going to have like a fraction, and that fraction is going to have like variables in it. So the reason I say factoring is very important is because we're going to have to factor these problems before anything else, and then we're going to reduce them. So let's go old school. You know, if you had like 5 over 10, you wouldn't answer 5 over 10, right? You would answer like 1 over 2. It's essentially what we're doing, but except now we're going to have things like 2 with x plus 4. So I'm not sure what's happening there. Okay. Oh, because I'm going up there. 2 with x plus 4 over x plus 4. So like the x plus 4s would cancel out and you have a 2. So let's go ahead and just kind of dive into it and reduce these rational expressions as we move on. So I have some steps here. We're going to factor as much as possible and make sure you look for GCFs and don't forget monomials do not factor. Don't forget, please, from chapter 6, an exponent of -1 means it needs to move. Now, there are absolutely apps out there. You can take a picture of this and it will solve it for you. Um, so I am going to ask that you provide your factoring on some of these problems to prove to me that you aren't just going to use outside websites. So your factoring skills, like I said, I have to be able to test the whole part of the problem, and part of that is your factoring skills. So let's take a look at example 1 and take a look for some GCFs. Sorry, just an email came through. So if I look at these two items and I look for a GCF, I am definitely going to see a GCF of 2 and x. So I'm going to factor this top by taking out a 2 and an x. So 6x squared divided by 2x is going to make 3x. And minus 10x divided by 2x is going to make a minus 5. That just comes from, old school factoring. Now the bottom's going to be a little more difficult to factor. I will factor this for you using the box method, but here's what I suggest. I suggest that you pause the video, factor it yourself, and then fast forward to see if you match my factoring. So the first thing I'm going to acknowledge is there's no GCF. I'm going to do 6 times -5, just like I did in chapter 4. I get -30. And -7 is what my magic numbers need to add to. So multiply to -30. So it's going to be -10 and +3. Those are my magic numbers. So when I move to the box, put 6x squared here. Now, if you're thinking I'm going through this pretty fast, that's because this skill was supposed to be mastered back in chapter 4. And if it's not, that's something we need to visit together at a tutoring session. So take a GCF going down these two. The GCF is going to be 2x. GCF going down here is going to be a +1. GCF here is a 3x. GCF here is a -5. So my factoring is 2x plus 1 and 3x minus 5. And hopefully you can see that the binomial of 3x minus 5 cancels. And this is a great opportunity for me to tell you this monomial of 2x does not cancel part of this binomial. You can only cancel monomials with monomials and binomials with binomials. So my final answer is a 2x over a 2x plus 1. So we reduced it after we factored it. Now looking into this one, the first thing I'm going to take care of is I'm going to put this on the bottom. So I'm going to put a 2z to the 4th on the bottom, and I'm going to make my 2 look more like a 2. There we go, so you don't mix it up with a z. And I'm just going to kind of like pretend this doesn't exist now. Now looking at the top, I don't like how it's written backwards. Please make a note of this, that this is like written, like we want to, I'm just going to write, we want to rewrite this. Okay, the reason we want to rewrite it is because we want our variable to be first. Just make sure you state that somewhere for yourself, make yourself a note. We always want our variable, like our squared term, to be first, and we want it in standard form. And the reason we want that is because then we can look at a GCF much better. So the top has a GCF. What goes into 8 and 98? Hopefully you're thinking about 2. But because the leading term is 2 and it's negative, I want to take out a negative and a 2. Now watch what that does. If you divide -8z squared by -2, you get +4z squared. And if you divide +98 by -2, you get -49. And that might not look like an important thing, but two things happen here. The first thing that you should probably recognize is that this 2 and this 2 cancels. The next thing you should recognize is that this is the difference of perfect squares. Now, why would that be important? because the difference of perfect squares factors to their square roots. So the square root of 4z is 2z, or excuse me, I should say the square root of 4z squared is 2z. So we put that there and there. This came from chapter 4. And the square root of 49 is 7 and 7. One's a plus, one's a minus. And the denominator is z to the fourth. Now, other than that, there's really nothing else I can cancel. I factored it. I'm checking this is a binomial. It cannot cancel with the monomial downstairs. So really, this is our final factored and reduced form. All right, let's move on. Example 3 and 4 are extra practice if you need them. If you want the answer, simply use the app Photo Math and check your answers with their answer key. So part 2, we're going to talk about products and quotients of rational expressions. That simply means we're really going to have more than one fraction, and we're either going to be multiplying our fractions or we're going to be dividing our fractions. When you multiply rational expressions, see if you need to pull out a GCF anywhere. That's the first step of factoring. So we're just going to factor these things. And let's see, factor what you can. So if you need to either factor by grouping or factor using the box method, make sure you factor where possible. And then cancel anything on the top with anything on the bottom. And that also means like if it's on the top left of a fraction and the bottom right of a fraction, those can cancel. After you're done, multiply anything remaining together. Dividing is very similar. You're simply going to flip the second fraction and then you're going to change the problem to multiplication. So you're going to flip the second fraction and you're going to change it to multiplication. And multiplication. And then you're going to apply the same steps as you do as if you're multiplying them. So you're changing your dividing into multiplying. So you're going to look for a GCF, just like you did over there. You're going to factor what you can. Remember, monomials don't factor. Cancel, and then you'll be multiplying straight across. So it's only one extra step because the only extra step is you're going to flip the second fraction. So example 5, we have a multiplication sign, so we're not flipping anything. So I'm going to go look first for GCFs. I do notice the top left has a GCF of 3 and x. A lot of times people see a squared and they think, oh, I have to do the box right away. And that's not the case. You want to look for the GCF right away. So if you divide by 3 and by x, you're left with x, a minus, and a 2 because the 3x comes out of each term. I'm just going to draw like kind of like a line through those. I'm also going to try to color code these for you guys. This is not x squared anymore, so I can't like factor by grouping or factor by using the box or factor by guess and check. Now what I'm going to do is I'm going to go over to the top right. Now and some of you might be really tempted to be like, oh, Mrs. Landelli, these are perfect squares, so I can take their square roots. And I guess like you could, but this would be an imaginary factoring problem because this is a plus sign. Now let's make sure we're all clear. If that was a minus sign, if it was a minus sign, you would have 6x plus 11 and 6x minus 11 because you would do the square root thing. But that is not a minus sign. So guys, there's no GCF here. And it is not the difference of perfect squares. It's only the sum of perfect squares. That doesn't factor. Again, if it was a minus sign, it would factor. So let's take a look at the bottom left. This is a monomial, so that's not going to factor. There's no adding and subtracting. Now, it wouldn't be a good problem, right, if I didn't test your factoring skills. So let's take a look at this one. I can probably factor that in my head, but I'm going to go ahead and do this the long way so you guys practice your factoring as well. If I were you, I would really pause the video, try factoring it on your own, coming back and checking with my answer. So I would do 5 times negative 8 is negative 40 and they're going to need to add to negative 6. So I need two magic numbers. The magic numbers need to multiply to negative 40 but add to negative 6. So I'm thinking negative 10 and 4 fit the category. They multiply to negative 40 and they add to negative 6. Now, I'm good at that because I've been in math for a long time. You might need to sit there and do, okay, what's negative 40 divided by 1? That doesn't work. Negative 40 divided by 2, divided by 3, divided by 4, until you finally got an answer. So now I'm going to go to, I like teaching the box method. If you're a grouping person, go to grouping. So 5x squared, a minus 8, a negative 10x, and a plus 4x. GCF x, GCF negative 2, GCF 5x, GCF positive 4. That's my factoring there. So 5x plus 4 goes here. And what else do I have there? X minus 2. Okay, so let's see if anything matches on the top and the bottom. You essentially need to see this as one really big fraction now. And anything that's exactly the same on the top and exactly the same on the bottom are going to cancel. So I definitely see that we can cancel x minus 2 with this x minus 2. So those are gone. Now, I'm going to highlight the monomials because sometimes this is hard for kids to see. See this 3x and this 6x squared with the y? Those are going to divide. So I'm going to rewrite it because it's really jumbled together. I'm going to bring everything on the top over that I didn't cancel. So I didn't cancel my 3x yet. I didn't touch my 36x squared plus 121. I'm going to put it in parentheses. And on the bottom, I'm going to carry over my 6x squared y and my 5x plus 4. Now, I have a purpose in doing that because I want you to compare right on top of each other these monomials. So I know that 3 divides by 6 and it becomes a 1 over a 2. Because I like 3 divided by 6 becomes a 1 over a 2. I have a single x on the top. I have a double x on the bottom. So that leaves me with a single x on the bottom. And then the y is still just there. Okay, everything else comes over. So remember, I got rid of this x and I made this an x to the first power. So I have 36x squared left plus 1. Oop, I missed my 6 on my 36. Plus my 121. And then my 5x plus 4 comes over. Since this, and sometimes I see kids try to do this. They're like, oh, this x cancels with this one, but that's canceling parts of a binomial. You can't do that. You either cancel the whole binomial or nothing at all. So this is the answer. Let's go through and try that again. So what I want you to notice on example 6 is that they are all monomials. There is absolutely no factoring that happens in number 6 because they are all monomials, and monomials simply don't factor. Okay? Now, how do I know they're not monomials? There's not like a plus sign. There's not like a minus sign. They're all like one unit. So what I'm going to do is follow the dividing steps, and the dividing steps say to keep the first fraction and multiply by the upside down, or I could say the word inverse, of the other fraction. There you go. Okay? Or there's reciprocal, excuse me. So I flip the second fraction upside down. Now what I'm going to do is multiply straight across. You can cancel if some of you are like, oh, 6 divides by 3 and the a's cancel out and the x's. You can do that now. I'm just going to go ahead and multiply them all together. So that's a 6 with an, oh, look at this. Okay, 6x squared y a cubed. And if you're wondering why I put x squared, it's because this x and this x. And then the bottom, I have a 3, I have a y, and I have an a squared. So I'm just trying to line things up. Now I'm going to go ahead and cancel. So I know 6 and 3 becomes 2 over 1. The x squared is the only x squared. This y cancels with this y. And the a's, these two a's go away. This a turns into a 1. That's my answer. The 1 in the denominator is not significant for my final answer. Example 7, this is called a complex fraction. Complex fractions, you take the first fraction and you're dividing it, right, by the bottom fraction. So remember what I said when dividing. I know Ms. Donahue always said dividing by fractions is as easy as pi. Flip the second fraction and multiply. So we keep the 5 over 4, and we multiply by 1 over 8, and we end up with 5 over 32, which does not reduce. So that was like a basic complex fractions. Okay, dividing by fractions is as easy as pi. Flip the second fraction and multiply. Now let's take a look at example 8. Example 8 is a lot more intense, but it has the same idea. So I'm going to rewrite it. 6a squared plus 1ab. I put the 1 in there to be nice. You guys should remember there was a 1 there even if I didn't read it. Over a plus b. This looks very intimidating, but you'll be okay. Now, since this is the denominator, it's technically, right, like over 1. So I'm going to divide by a fraction is as easy as pi. Flip the second fraction and multiply. Now, I'm putting your factoring skills to the test. Let's go ahead and color code. I will do the top left in blue. And I will do, I'm hoping that you see, make that highlighter a little bigger. I'm hoping that you see this can't factor because it's not squared and there's no GCF. So that one's done. And let's do this one in green. That one's definitely going to factor. Okay, let's try this. I'm going to switch to blue, and we're going to really test your factoring skills. Your factoring skills, like I said in Chapter 8, your factoring skills are incredibly important. So I'm going to do 6 times negative 35, and whatever I get, I need to end up with that positive 1 when I add them. So 6 times negative 35, let's see, it's negative 180, and then another negative 30. So negative 210 when I multiply. I need two numbers that multiply to negative 210 but add to 1. I'm thinking, well, I can't do 10 and 21. Like, now you might be like, well, how did you even? So I know, like, if I do 10 times negative 21, I end up with negative 11. So that's no good. So you're going to see me struggle through this, but that's okay because I figure, like, if I'm struggling through it, you're probably going to struggle through it too. So I'm going to dual screen here with my calculator. Let's see, I know the numbers have to get close together because I have to end at a negative 1. So let's do 210 divided by 15. Oh, look, I got it. It's 15 and 14. Okay, so it's 15 times negative 14 multiplies, I just kind of got lucky there, multiplies to negative 210, adds to positive 1 because we didn't want negative 11. So I got my magic numbers. Now, if you're a grouping person, go ahead and group it. If you're a boxing person, box it up. Okay, so what do we have here? It's 6a squared in the top box, and it's negative 35b squared on the bottom. Magic numbers 15, a with a b in this problem because I have a and b, a with a b. People really kind of freak out when they see a double variable. You're just going to throw an a and a b on there. Okay, so GCF here is 2 and an a. GCF here is a positive 5 and a b. GCF going left to right is a 3 with an A and a negative 7 with a B. Again, factoring skills have to be spot on. So what I'm going to do, what I find beneficial in these type of problems is to rewrite them with the factors. Okay, so top left. Top left, I'm going to rewrite 3A minus 7B and 2A and plus 5B. So I did my factoring. If you are simply watching me factor or you're fast forwarding for me to factor, you are not doing your job. You are not going to do well, probably on the homework. You need to practice yourself. So 1 does not factor, and we already said A plus B does not factor because there was nothing squared on it and there was no GCF. Now it's time for us to factor this green one. Again, your factoring skills have to be spot on. You should be able to factor this on your own. So I would encourage you, please pause the video, try it yourself. So I'm going to do 2 times 5. Middle number is 7. That's 10. So I know my magic numbers are 5 and 2 because they multiply to 10, add a 7. Go to your box. 2a squared, 5b squared, 5ab for my magic number 1, 2ab for my magic number 2. GCF is 1a, GCF is 1b, GCF is 2a, GCF is positive 5b. So I'm going to go ahead and put that in my bottom right. 2a plus 5b, 2a plus 5b, 1a plus 1b, which I'm just going to leave as a plus b. And I am going to go ahead and cross cancel and like up and down. You can just picture this again as one large fraction bar. That's perfectly fine. You're allowed to do that now. So 2a plus 5b is on the top. It cancels with 2a plus 5b on the bottom. Do not cancel the a plus b's because they're both in the denominator. So what didn't I cancel on the top? I did not cancel a 3a minus a 7b and the 1. And on the bottom, I did not cancel an a plus b and the second a plus b. Those did not cancel. So to rewrite this like prettier, it would be really nice if you guys could see that that's just going to be 3a minus 7b because who cares about the 1? And then it's a double a plus b. So we'll write it like that. All right. Now, example 9, you should be able to say they are all monomials. So I have nothing special to do. In example 9, there's no box or anything. These are just just straight up multiplying and dividing. So keep the first fraction. Don't change it because it's the first fraction. Okay, dividing by fractions is as easy as pi. Flip the second fraction and multiply. So I took care of that rule. And then that's a multiply sign, which means just leave me alone. So I just had to flip the middle fraction. Now, different people are going to do this different ways. I will probably just encourage most students to multiply straight across. So we have, so the next thing we're going to do is multiply straight across. So we get 12, and let's see, that's going to give us a p squared, and it's going to give us a q to the third power with an r. And change that to so I can write a little better here. And on the bottom, we have a 3 with a variable p, a q squared, and an r squared. Now, you should be able to see that 12 divides by 3 to give you 4 over 1. This p squared cancels with this p, and you're left with a single p on the top. This q3 cancels with this q2, and you're left with a single q on the top. And this r cancels with this r squared, and you have a single r on the bottom. So the final answer would be 4pq over r because the 1 is implied. There are extras if you need more practice. I will just start 10. And then if any of you feel like you need more practice, which there's a good chance that a lot of you are going to need some more practice, I would do this problem. See how you do. Check it out with photomath. You're going to need to factor that, and you're going to need to factor that. All right, let's take a look at number 11. Number 11 is really going to test your skills. Got some more, boxes, factoring, and all that stuff. Now, your factoring skills, they need to be spot on. Okay, I know I've said that like 5 times in this video. I'm going to color code blue. I'm going to color code what other one? Orange. I'm going to color code green. What other color can I use? Red. Let's see, purple. And randomly pick this beautiful brown color. Okay, so let's start with blue. Remember, this fraction is going to flip, and this fraction is going to flip. Okay, very slowly, I'm going to go through one by one. I'm going to look through a GCF. The blue has no GCF, so I would have to do 3 times -2, which is -6, add to +1. My numbers are a +3 and a -2. Okay, I can factor fast. I should be able to, right? 3x squared. It would be bad if I couldn't. What's the bottom? -2y squared. You should pause the video and try factoring on your own. So I fill in my magic numbers with a +3xy and a -2xy. And now I'm going to go ahead and get my GCF. So this is a 1x, this is a +1y, this is a 3x, and this would be a -2y. A lot of people really have trouble with this double variable thing. The long story short is you just put the double variable xy on your magic numbers. But I'm going to fill that in on the top left problem. So I'm going to get 3x minus 2 and 1x plus y. So let's see, I'm going to draw my color codes. That's going to be here. There we go. So the blue goes on the top left. So 3x minus 2y and 1x plus 1y goes right there. Now I'm going to move to the bottom left, which is red. So I do 3 times -2, which is -6. My middle number is -1, which makes my numbers -3 and +2 for my magic numbers. Going into the box, I'm going to get 3x squared in the top left box and -2y squared in the bottom right box from my red equation. I'm going to fill in my magic numbers of -3xy and +2xy. So -3xy with a +2xy. Find our GCFs is, let's see, 1x minus 1y. And what do I have going down here? 3x plus 2y. Fill that in on the bottom left, x minus y. 3x plus 2y. Yes, I didn't put the ones on the x and the y of the first one because it's not really that important. All right, let's move on. Now you see the orange. The orange I'm going to factor, but I'm going to put the answer on the bottom. So the orange is going to be 3 times -6, which is -18, and I have to find two numbers that multiply to that and add to +7. So it's going to be +9, -2. Go to the box, we get 3x squared on the top, we get -6y squared on the bottom, 9xy, put double variables on it, negative 2xy. GCF is 1x, GCF is positive 3y, GCF is 3x, and GCF is negative 2y. I know it seems like I'm factoring fast, but factoring is a skill that hopefully you acquired in chapter 4. If not, that's something that probably needs to get revisited after school sometime during a tutor session. All right, let's go ahead. I'm just double checking my answers with my answer key as I move along. So give me a second. I don't want to do this wrong. Okay, so purple. So we got purple now, and I'm going to do 3 times negative 1, which is negative 3, middle number negative 2. So that's going to be a negative 3 with a positive 1. That multiplies and adds to the proper numbers. All right, so my purple box is going to be 3x squared up here from the equation, and it was negative y squared, I do believe. That is true. So my magic numbers are negative 3xy and a positive 1xy. So my GCFs are correspondingly 1x, negative 1y, and 3x, and positive 1y. So that's going to go in the purple on the top. Dividing by fractions is as easy as pi. Flip the second fraction and multiply. That's why I flipped the purple and the orange. Oh, and good news, the green and the brown. So the green, there is no GCF and there is no squared. So the green just needs to go to the bottom. Yay, no factoring on that. Now the brown, there is a GCF of 2. I've already labeled that. So I'm going to pull out my 2 and I'm going to be left with 3x plus 2y. It is important to remember to look for your GCFs when possible. Now we have the fun part. This is the canceling part. This is my favorite part. So we're going to match anything on the top, anything on the bottom, and cancel it. Do I have a 3x minus a 2y on the bottom? My denominator. I sure do. That goes away. I'm going to change the pen to be a little bit thicker so I can really see things cancel out better. Do I have an x plus y on the bottom? I do not. Do I have a 3x plus y on the bottom? I do. Do I have an x minus y on the bottom? I do. Do I have a 3x plus 2 on the bottom? 2y? I do. Do I have an x plus, okay, that's it. That's all the cancels. So my final answer is what's left. So on the top, I see I have a monomial of 2 and an x plus y left. And on the bottom, I see I have a binomial of x plus 3y. Please don't try to cancel these x's. That would be canceling bits and pieces of a monomial, which is not allowed. That is your final answer. It was fun. Okay, example 12 was our last one. Example 12 I have on here because you're going to see sometimes that things are written backwards. See that right there? We are going to rewrite that so that it's negative x plus 4. And maybe you're wondering about why would you do that, Mrs. Langeli? Because then you can hopefully see that there's a GCF of negative 1. Since there's a GCF of negative 1, I'm going to rewrite that as a positive x minus a 4. You always want your leading term to be x, and you always want your leading term to be positive. So if your leading term is negative, pull out a GCF of negative 1. Over here, I'm going to notice is the difference of perfect squares. And yes, you should be able to see that by now. So you're going to do their square roots. So I'm going to do the square root and the square root. One's going to be a plus, x plus 4. One's going to be a minus, x minus 4. I see I have an x minus 4 that matches identical. My final answer is negative 1 over x plus 4. The last part of this video, I promise, is talking about restricted values. Let me tell you a little bit about restricted values. Restricted values means they're the values of your variables that would make your denominator 0. Because remember, if your denominator is 0, the world blows up. So if we have x plus 4 over x minus 5, the restricted value is positive 5. Because if you put positive 5 in the bottom, you get 0. That's an example of a restricted value. If you have 2x plus 1 over 2x plus 1, you might think that you cancel and that you do cancel at the end. However, you still have a restricted value because you had a variable in the bottom. So you have to think about this one more. You have to say 2x plus 1 is not allowed to be 0. 2x therefore is not allowed to be negative 1. X is therefore not allowed to be negative 1/2. That's called a restricted value. And then you would continue and cancel that problem. Let's say you have 3x minus 4 over 2x plus 5. What's the restricted value? Well, 2x plus 5 is not allowed to be 0 or the world will blow up. So we're going to take away the 5, and then you're going to divide by the 2. So the restricted value is negative 5/2. So if you ever see something that asks you about restricted values, you simply take your denominators that have been factored, and you say that they can't equal 0, and then you say what the value of x would be. That would make them 0. Those are restricted values. All right, I know that you thoroughly enjoyed that lesson. I can't wait to see how well you do on the homework.